Okay, good evening everyone. So welcome to 23rd day. So today we'll be seeing generally in functions we use like parameters and arguments interchangeably. But what exactly the parameter and what exactly the argument I will see today. Let me share my screen. So if we go here, so generally let me see this function definition. So if you see generally we define a def of my function and then it's something is the parameter, like we define some variable name. So it's like, so this is called parameter. If we are defining something like something variable, it's a parameter. But if we are passing a value to this variable, then it's like argument. So generally when we define a uh, function with some parameter, like then it's like a parameter we call say. So generally functions will have multiple parameters, but when we are calling functions we pass the arguments to that function. So but generally we use it interchangeably. Functions and arguments are similar but little bit difference. So they are like blueprints of the function, and then arguments are the actual values which we pass to that parameter. Uh, so if we more language, uh, like if we for definition greet, so just name. So here I'm just printing hi. I'm using f strings. Hi, hi name. So if we, this is the parameter of the function, like greet is the function, and here we are printing this. So now when we are calling greet, we are calling the function. So I am passing name, my name. I, then if I save demo dot underscore parameters. So if I call it, okay. So I haven't defined properly. Okay, so I forgot. So we have to include in flower brackets, right? So generally, so then it will take it as variable, otherwise it prints the string. So here there will multiple like we can give location, print f of location. So again this should be inside flower brackets. So here I am giving RJY. If I run again, so it's printing. So but if we interchange these variables, right, so if we interchange this to from, so it will, like, it's a position argument. So whatever you pass in the first place, the parameter, the argument will go to that parameter. So you cannot interchangeably use. So if you want to use that like interchangeably, like, then you have to call it as keyword arguments. So this is the keyword argument we are passing. So you can give anywhere, like instead of here we can give. Okay. So here the positions are yeah, as interchanged, but what I have given my argument, my RJY argument to the actual parameter what we have defined. So if I again call this, so it haven't, so the same output I have come back, even though I have just interchanged the positions also, there is no change. So this is all about parameters like keyword arguments and position arguments. So, so generally, if you don't define the keywords, they will take by default whatever you pass the first argument, they will go to the first parameter. So now there will be only two exercises, very easy exercises. So paint area calculator. So imagine you are painting a wall. So one can of paint can cover 5 square meters of wall. So it's like given a random height and width of a wall, calculate how many cans you can and you will need to buy. So for example, they have given this number of cans equal to wall, like this is the height and width divided by coverage per can. So they have already said the coverage per can is 5. So this is area. So generally the rectangle area will be a height into width, right? So the similar kind of area divided by the area divided by how like how much one can paint, how much, like 5 square meters it can paint. So if you see 2 into 8 2 into 4 8 divided by 5, it is like 1.6, but we can't buy a zero 0.6 can of paint, right? So here we have to round off 2 cans, but again if you we use round function, it actually round to 2, but if we want to, if we have got the answer as 1.3 and we have used round, it will actually reduce to 1, but we want actually to buy 2, well I want to say we have to buy 2 cans, right? Even it is 1.1 and 1.2, we can't adjust it in with 1 can. So whatever the extra point we have to buy the next can. So here, so if you see the example input, so they have given 3 to, so it's like 3 into 9 27 divided by 5, something like 5 point something, 5.4. So it is rounded up to 6 cans. So they have given some hint how we have to do that, but before we will write a simple program. So it's like first input, so what is the input? Enter height of wall, enter height of wall. So we are asking the user to enter height of wall. So height wall, width underscore wall equal to enter width of wall. So coverage is equal to 5. So they have already given coverage as 5. So if you take again, so the coverage, so one can cover only 5 square meters of wall. So square meters in the sense the area of the wall. So it can cover only 5 square meters area of the wall. Now, now we will define the function required. So here what we will take, height with coverage. So I can get coverage per can. So generally now what we are doing, so it's the number of cans required is like, so I have defined a function and I have taken 3 parameters, and then I am writing the process number of cans required equal to, generally it will be height into width and then divided by coverage. So after that what we have to do, so generally I will got this output. So now so generally instead of calling function also we can directly write, but here we are defining parameters and arguments. So using that concepts we are actually defining. So now just as required equal to, I'm just calling the function. So here I can directly give this on this and this, like all that, but we are, instead of using position argument, we will be using keyword arguments. So height equal to height wall, equal to width, cans per can. So there is uh, issue. So if we do this, it will say us in points, right? So if we give some random numbers, if you see here 1.6, but we don't want in 1.6. And so just I'm saving it. So now we will go to the hint. So here, if you round the number, for example, 2.3, if you use round function, what we have already used, it will round off to 2. But we need, if it is 2.3, then it should round off to the higher number, like 3. So we need 3 cans because we can't use zero point 0.3 cans, right? So in that case, what we will be doing is, this is the function, like math.ceil is the function. What it will do, it will actually round off to the upper, I meant to say, if it is x.1 also, then it will round off to the next integer digit. So when you use ceil like 4.2, it will round off to 5. Similarly, it's for Python 3 and Python. So it's a straightforward function. So for this, what we need to do, we have to import math module, and then number of cans required equal to math ceil number of cans required. So in this way, so now what we did, we actually doing, so if it is even 0.1 also, it will be rounded up to next integer. So in this type of cases, we will be using the ceil function. So now let's run the program. So just I have height of the wall 5 and width of the wall 7. I am just okay. Sorry. Okay, the input function we haven't converted to int, right? Because it will be int only. One second. So we have to convert to int, right? 7. So now it actually converted to int. So like 6 divided. like 6 into 7, it will be 42,
Or
42.
if you are converting to decimal mean,
Yeah, we are converting decimals to higher integers because for example, the area required is for example, again go back. So for one can you can paint only 5 square meters, but the area is 1 point like 8 square meters. So for with 1 point you can paint one can you can paint 5 square meters, but another 3 square meters how you can paint? You should have another bucket, right? With the same one can of paint you can't paint it. So that's why what we are doing, we are actually converting this decimal to the higher integer. Not like if you use round function it will convert to 1, but that's not required for us. We have to convert it to the next integer, like because uh, for painting you should require two cans, even though it is sufficient only half of the can, then we have to have the other can, right? Even it is 1.1 also we should have another can. So at that time how like uh, this the requirement so that user can buy two cans to like to paint all the wall. So that's why you are using ceil function to convert decimals to integers, but it's like the next rounding off to next integer, not higher integer, not of like if you use round function, if 1.5 it is less than 5, it will round up to uh, the down integer, like it will round up to 1, but if it is greater than 1.6 or it will round up to next integer. But instead of that, if you want only to round off to next integer, then you have to use this ceil function in math.
seal, floor, and truncate these are the SQL functions. Huh?
Sorry, ceil.
Seal, floor, and the trunk is the SQL functions, huh? Or Python
These are
is the
Python functions only. In math module, it is like we use
yeah.
square root.
SQL. That's why I'm asking.
These are Python functions. We called a ceil function from math module. Similarly, you can like factorial function. Multiple functions will be there. We have used square root function already. Square root. Round also we have used rounding off.
Sir, from yours, someone getting disturbed.
Uh, my voice,
No, not your voice.
my screen. I meant to say.
Somewhat getting disturbance from your side, sir, not your voice.
Okay. Okay. 1 second. I will try. So this is the paint area. I meant to say. Yeah, paint area we have done. Now we will be checking prime number. Uh, so again, prime number. What is a prime number? Is like if it is divisible by a 1 and itself, then only it is called as prime number. Otherwise, it is not a prime number. So and generally, 1 is not a prime number. Only from 2 it starts. The prime numbers will start from 2 only. So now if we take another like function, so let's ask again int of input enter any number. Let me go to Python, n equal input number equal to int of. So here we are taking the input from the users to saying any number from. So here what we will be doing, we will be writing a function prime number checker. So and we are defining, so we are giving only one integer. So here what we will define first, if number is equal to 1, then print the number is not a prime number. Now then again what we will do, else if. So now what's the logic we are implementing? So it should be divisible by 1 and itself. So it's like when you are dividing with the number with any other number, like you are doing a division. If it is returning a remainder as 0, then there is the factor, right? So if I divided by 8 with if I take 8 or 4, 4 is actually divisible by 2 and 4 is divisible by 4 also. So similarly, what we will do, we will check a flag, we will keep a flag is prime just before true, then for just I am taking for I in range of, because one we already checked, so now it will, the range will start from 2 up to the number, and then now again writing if number module, so I double equal to 0, and then equal to false. So here what we are doing, we are actually dividing the number from range, like if it is 2 to, like if I given 2 to 4, and then it's like every time it runs, right? Every time it runs from I from 2, and then it actually divided. So I will be I want to say the step increment, I want to say. So here when we divide with the same number or the loop, right? 2 divided by 2, it's equal to 0, and 3 divided by 3, and 2 divided by 4, so it will loop through all that numbers, and if it is having multiple reminder, if the reminder should not be 0, because then it says it is actually divisible by another number also. So So that's why we are keeping like is prime equal to false. If it is divisible by another number also, then only we are getting the remainder as 0. At that time, what we are doing, we are keeping is prime equal to false. So we are changing the flag. So once the loop got terminated, then if is prime like equal to true also we can go, but generally we should use is prime is similar to is prime equal to true. So anything else? So let's check with this. So any issues with this, like any doubts? So we are just checking the number whether there are factors or not. Generally the prime number should not be divisible, so it should not return uh, like 0 when it is divisible by other numbers. So if it returns 0, then means it is not a prime number. So that's the logic we are implementing here.
Can we use mod functions?
Modulus also you can use. Yeah, generally this is only this is modulus only directly, but you have to import a math dot mod this. But that modulus is entirely different, right? Uh, yeah, you can use it. So here, if we are working with integers, then this modulus is preferred. But if we are working with floats, then you can use this function f mod. Generally, no, we are checking for only integers. We are checking floating point number. And floating point numbers is never be a prime. So that's why we are using this modulus operation. Python of path. Sorry, for else if statement, or I can use else also, but just I am giving else. So and again I can close it with else also. If number less than 0, it's you entered negative number, something like that we can say. But as of now, just I am using this. I'm just using 4. I'm expecting it should not be. It's not a prime number. Sorry, I haven't called a function. I'm just checking. So that's why we have to call the function, and then I'm giving number equal to input number. So 4 is not a prime number. So let me check. 2 is a prime number. Mm, is a prime number. So it's working. If I check for maybe 73, 73 is a prime number because 73 I don't see any factors for that. So you can check for another solutions also, but this is one of the easiest solution what we have got. So yeah, that's it. So any questions again? More questions? So mainly we covered parameters, keyword arguments, positional arguments. Yeah, difference between them, and then we have using keyword arguments only. We are actually passing the values to function using keyword argument. Generally, keyword arguments are preferable, and it's easy to read the code because yeah, because what is the variable you are passing and what is the function parameter, you can see both, and it doesn't depend on the position of the uh, like uh, parameter position in the function.
Why we know is prime is equal to true?
We have to define, right? We have to define something.
Without defining, we can't do that, sir.
So because here we are giving if is prime equal to true, this is equal to this thing, right? So without defining, the code will fail because you have to define something here. So if I not define, so generally we are assuming whatever we are the input user is giving, it is a prime number, but we are checking further. So if you won't define, then the code will fail again. So it is not saying, so it doesn't know what to check because we are saying you have to check is prime equal to true, and we haven't defined the variable. What is the variable value we haven't set to it. But
But
in
without defining, we write the statement like with the if and else
mhm,
in two line.
sorry, where
Without defining, can you write the statement like with the if and else statement? We can print the number also the prime number or not.
with an if and else statements you meant to say, like without
Yeah,
checking this one. But
Yes.
we have to check some condition, right? So how we know that is a prime number or not? So here we are defining a flag which turns whether it is a false or not. If we don't define this, then which condition you will check? You can define maybe another logic also, but here what we are defining it is the flag logic. We are changing the flag. That's why it's a condition we are using this one. So if we remove this also, if what we have to give the condition, right, what condition it is. If you want to give the condition, then obviously it will fail. It's invalid syntax it is saying. Because if you are writing if statement, there should be some condition to evaluate. So the condition is prime, we are checking. If it is true or false, we are checking in the condition. Depending on the true or false flag, we are then printing the number. So this is the logic we are written, but for this logic we have defined the variable is prime to true or false. Even if you don't need to like if you can just define is prime equal to 0 and is prime equal to some 1 or something you can give. Here then you have to change the condition again. If is prime is equal to 0, then the number is a prime number. So it's like prime number. But else if any other condition, then it's like it's not a prime number. Even now this condition will work. So it's just a definition of what we are defining and what we are seeing. I just made true or false, that's easy to identify. Like okay, this is true and this is false. Even you can define even this will work if I give this number and 4. 4 is not a prime number. Even 2 is not a prime number. 5 is a prime number. 6 is not a prime number. Yeah, it is working fine, but so here this is the logic what we have defined. So we are creating a variable conditions and then we are checking the conditions in the if statements. So just not because like booleans. Better to use booleans because there will be only two values, right? True or false. So and it is easiest to understand. So first what we are doing, so sorry, it will be true and it will be false. So and if we read the code normally also you can understand, right? Okay, this is prime equal to true here defining. So and then is prime is false. False is so it is not a prime. Here itself we are defining the number is not a prime. So now if it is equal to true, then it is a prime number, else it is not a prime number.
Okay, sir. Clear.
Okay, thank you. Then no questions. Stop recording.